The habitability of red dwarf systems is presumed to be determined by a large number of factors from a variety of sources. Modern evidence indicates that planets in red dwarf systems are unlikely to be habitable, due to their low stellar flux, high probability of tidal locking, small circumstellar habitable zones and the high stellar variation experienced by planets of red dwarf stars, impeding their planetary habitability. However, the ubiquity and longevity of red dwarfs are factors which could provide ample opportunity for any possibility of habitability to be realized. As red dwarf stars are by far the most common type of star in the universe, astronomers study how each of the many factors, and the interactions among them, could affect their habitability to learn more about the frequency and most likely locations of extraterrestrial life and intelligence. A major impediment to life developing in these systems is the intense tidal heating caused by the proximity of planets to their host red dwarfs. Other tidal effects reduce the probability of life around red dwarfs, such as the extreme temperature differences created by one side of habitable zone planets permanently facing the star, and the other perpetually turned away and lack of planetary axial tilts. Non-tidal factors further reduce the prospects for life in red dwarf systems, such as extreme stellar variation, spectral energy distributions shifted to the infrared relative to the Sun, and small circumstellar habitable zones due to low light output. There are, however, a few factors that could increase the likelihood of life on red dwarf planets. Intense cloud formation on the star-facing side of a tidally locked planet may reduce overall thermal flux and drastically reduce equilibrium temperature differences between the two sides of the planet. In addition, the sheer number of red dwarfs statistically increases the probability that there might exist habitable planets orbiting some of them. Red dwarfs account for about 85% of stars in the Milky Way and the vast majority of stars in spiral and elliptical galaxies. There are expected to be tens of billions of super-Earth planets in the habitable zones of red dwarf stars in the Milky Way.